Okay, so here's a quick video on how to identify the angles. And we will start with identifying the relationship between angles 1 and 4. So these two angles. So the first thing to notice is that 1 and 4 is on what I like to call a full line. So one long line. Compared to this, I just consider this to be half a line because it doesn't go all the way down. So I know that's not an official math term, but that's how I like to see it. So this is one full line and it's perfectly straight, meaning that both of these angles is going to be equal to 180. And another important thing to consider as well is that angle 1 and angle 4 is separated by a common side. So a half line right through the middle. So because of that, angles 1 and 4 are linear. Okay, so let's look at another example. We will do angles 4 and 5. So angles 4 and 5, and same thing, they are on a full line, meaning both of them total to 180. They have a common side right here, right in the middle, so that's also linear. Let's do angles 2 and 3. So we have angles 2 and 3 here. I know, I'm sorry, it might get confusing now. I'm just starting to draw angles everywhere. Maybe I should erase some things here. Okay. Close enough, but we have angles 2 and 3. Now, angles 2 and 3. Angles 2 and 3, it's not on one full straight line, right? It's bent. It's like at a corner here, but they do share a common vertex, so common point right here. It's separated by a common side, so an arrow straight through the middle. And because of that, these angles are adjacent, but it's not a straight line, so it's not considered linear, but it is adjacent. Let's do another one. So I'm going to erase this here. Let's do angles 3 and 5. So that's these two angles right here. Now with angles 3 and 5, they share a common vertex, so a common point that both of these angles are connected to, and a common side that splits the two angles in half. So this is also adjacent, but because again, it's a bent shape, right? It's not a full straight line. It's adjacent, but it's not linear. Now let's look at the last one. I'm gonna erase this here. So those were adjacent. Let's look at the last angle. We're gonna look at angles 1 and 5. So with angles 1 and 5, the easiest way to remember vertex, at least in my opinion, is that these are two angles here. But notice with the angles, they are diagonal, so to speak, whereas the ones we did that were adjacent, the angles like 3 and 5 are side by side, or 2 and 3, those adjacent angles side by side, but these are diagonal. It almost forms a bow tie. You can kind of think of it like, you know, a bow tie. Okay, that's a really ugly bow tie, but you see where I'm going with that analogy. And another way you can characterize this is that unlike an adjacent angle that had a common side, so a half line sticking right through the middle, there is no common side separating them. Well, I mean, it's not like, I guess I should rephrase that. So it's not like the angles that are side by side with a common side separating them, right? Because it's not the same. There's an arrow here, but it's not separating two angles that are side by side. These angles are completely opposite from each other. So that's how you know that's actually a vertex, when it forms that bow tie. So here you are. I hope this kind of helped, but if you have any other questions, let me know. I'm a night owl, so I'm here if you need me.